I will start now, teacher. Nói luôn. Good afternoon, teachers, and hi everyone. My name is An, and I'm from Group 1. Today, we will talk about network simplex method and the upper bound technique for the minimum cost flow problem. So there are three parts of our presentation. First one is the introduction. In here we have the minimum cost flow problem. Next one is network simplex method, and the last is to incorporate the upper bound technique. The second one is algorithm, and the last one is the application. So let's get started with the introduction. First one is about the minimum cost flow. So, as you can see, consider a directed and connected network where the node and node enclose at least one supply node and at least one demand node. The decision variables are, as you can see on the slide. Now we will focus on the formulations. The objective function for this minimum cost network is quite simple. Minimize the total cost of all flow that are going through our network, which means that we are going to multiply the number of units that is going through the RIJ times the cost of transporting each unit of flow through the RIJ.
Excuse me, Hong Ang, you talk like this. It sounds like a reading some story. So it's quite hard for us to understand. You should just show me what is the problem with the upper bound or something like this, and look at the figure, and then you can talk. It's all like this. Very hard to follow.
Okay, teacher. Okay, so we will move on to the example for you to easily to understand. You can say at the above example can be solved by using linear programming method. And one of them is the simplex method with a simplex tablet. However, this problem can be rewritten in a network structure. Then the network simplex method is more transparent and more productive.
Hey,
Net
hey. As I tell you, the network problem we know already. Is that okay? And what you are thinking is about the incorporating this problem with the upper bound technique. Is that okay? So what is the problem with the upper bound? You just had tell me. Tell me, for example, this problem is different from the normal problem we studied before. At what place? Where is the difference? And you just focus on this, how to solve the problem with this. That's all. You know, I tell you clearly, you don't need to repeat the problem with what is the problem of minimum cost flow network or something. No necessary. Just problem with the upper bound. What is it? What is the difference between this problem with the normal problem in the lecture notes? And how can we solve it? That's all. Okay, so this is a problem with the upper bound. Is that okay? So where is the upper bound? What is the difference between this problem with normal problem we learned before? That's all. Shortly. Come on. Okay.
Yes, teacher. So here you can say this is the example for the upper bound techniques. This upper bound technique is used to do efficiency.
You have to you have to to distinguish the problem with up about, you know, and the techniques of solving this problem. Up about techniques means the method of solving. And the problem with up about is something else. You understand? You have two things. You have to distinguish two things. Okay, look at this. This is the problem with up about, not technique at all. Is that okay? You understand? This is the problem with up about. And the way, the technique or the way we solve it, then we call technique, okay, with the up about or something like this. But this is a problem with up about. So the problem with up about, what is the difference between this and the normal problem? That's so very easy. Very simple. This is exactly the same like a normal problem. Is that okay? You have a Uij, you have the cos and something, everything is okay. Bi, for example, the B is a supply node, A supply node, D is demand node, E is demand node, C is intermediate node or something like this. But there is something more here, okay? It's something CAB, CAD, or UACE or something. What is it?
So the difference of the upper bound here is the UAV here in the first picture is equal 10, but on the second picture it's the UBA equal 10.
Plan the first bit first. In the process of solving, it is changing or something like this. Just the initial problem is the figure 1. Is that okay? UAB is what? UCE is what? And CAD is what? You see? Mm. Continue, ông Ang.
Yes, teacher. So you can see that OAB and OCE here is the capacity of this is the art capacity and
Something we couldn't hear you clearly, so be close to the microphone. Say it again. Start again, Hồng Anh. Quickly, it takes
yes,
time.
can you hear me clearly now?
Yes.
Sure. So in the picture, so you can see that OAB and OCE is the art capacity. And but in the second picture, the UAB is just think versus art. So this is the difference between the upper bound technique and
No. Just very simple. I don't know why you think of something else. You know, in the normal network problem, we don't have a UAB. Is that okay? And the difference here is the appearance of UAB, UEC, and CAD or something like this. So what are these? Just that's all. And the change from the first figure to the second figure is another thing. It's on the process of solving, you know. On the process of solving, you change. But I don't want to, I have not yet tell anything. You just to show us the problem you are given here. What is the difference between this and the normal problem? Just one thing. The appearance of UAB and UCE or something like this. What are these? Why is it difficult for you? So funny. What is UAB?
Yes. The UAB is the upper bound of the XAB.
Upper bound, but upper bound means what? You know, you say upper bound, people cannot understand what does it mean upper bound. Hey, what is upper bound?
It is less than or equal.
What is less than or equal?
The XAB is less than or equal to UAB.
So that means that the maximum of capacity that you can move along this, is that okay? If you transfer the amount of good from A to B, then the flow XAB never can exceed UAB. The maximum can be like this. You can move 5, 6, 7, 8, 9, and also 10, but cannot more than 10. That is the capacity, you know, the maximum capacity of the flow. You can move around this arc. That's okay? That's all. And the CAB is what? CAD is what? Some other student in the class in the group can explain for her.
In this, CAD will be the cost when you transfer one unit from A to D. This means C. What C means?
It's the cost, so means that if you just so for example, the cost from A to C, one unit from A to C is what?
The cost, the CAC, the cost move from A to C will be 4, will be the number on the arc, number 4.
Okay, they write down here, they just to show you the number on the arc is the cost. Is that okay? So all the other number on the arc are the cost of moving one unit from this to another node. Is that okay? And the difference here is only UAB and UCE. And the technique for doing this, then what is the key points, you know? Can you tell us what is the key point? Also, you can continue with your the method of solving this problem. For example, tell me. So how do you do this? How do you?
So the next to solve this problem is my friend Mai will tell you about it. Okay.
Okay, to solve this problem, we will have the algorithm, and it will have like 5 steps to solve it. So first is the step 1. we need to computing the dual vector y by solving the following system. As we know that the Cij equal yj minus ye, where the Rij belong to T, where T is the tree from the given. And
So,
we
excuse me, T is what?
T here is when in the tree from the beginning. And if
The tree from the beginning, where is the tree from the beginning? You show me the tree.
can you move up? Yes. And here is the from the visible tree we will have the visible tree and T is the visible tree. So
Where
the
is it? Where is this? Where is the visible tree?
so this is the visible tree.
This is, you have two figures. Which figure?
On the right hand side.
The second. The second is visible tree. No.
Oh, sorry, not this one.
That's the whole tree.
Yes.
The whole network. Tree is what? Tree is a network which have no cycle, but have a lot of cycle.
Yes.
Oh my God.
Can yes, like this is the visible tree.
You I don't know. Let me check.
Teacher, I can tell you something because my group has
Yes.
the order that we first we tell the algorithm, then next we will have an example to show you that we to show that about the upper bound section. We will have an example about that later on. It's all right, sir.
You I understand your idea, but you have to say, for example, first of all, before the algorithm, you have to do what? You cannot say, okay, start algorithm. You have to do what?
Explain some key point in the algorithm, right?
Explain key point on the algorithm. No. What? All the 5 people in the group. Before saying about the algorithm, you have to do what?
When you deal with the upper bound, when you deal with the upper bound problem with upper bound, then first thing is you need to choose what is the reverse arc. The reverse arc will be the way you let the unit transfer to reach its upper bound, and then you will reverse it.
No.
And
You say you just start the algorithm and you do the step 1. Is that okay? There is nothing related to the reverse, not everything. You just do like that. You compute the dual vector y1, yn. Is that okay? No reverse, and not anything. But the one very important thing here is the t. You have to tell first, choose a feasible, initial feasible solution tree T, you know? Without T, you cannot do anything. You write down everything T here. So what is T? It's like the linear programming. If you want to talk about the algorithm for solving linear programming, first of all, you have to choose a feasible solution. And from that feasible solution, you can improve to get the better one. Is that okay? So now the first step is, before start the algorithm, you have to say choose T is the initial feasible tree solution. And you base on this, you improve it to get another tree solution, which is better. That means the cost is lower, cheaper. Is that okay? So you have to say first, let T is a feasible, initial feasible solution, tree solution first. And then you have something like IJ belong to T or something like this. And just say very quick, because what? The step 1 is the same like step 1 I teach you. Is that right? Any difference? The step 2, calculate C bar IJ, the same. Is that right? But you have to come back to the example. You will use the example to illustrate your algorithm. Is that right? Is that right? You will use this example. So for the normal network problem, you know how to find out spanning tree, how you find out the initial feasible tree solution. Is that okay? But for this problem, which is different from the normal network problem, so how can we find out the feasible tree solution here? You can show us one example about the tree solution here. You understand? You have to think of it, and you think it's I don't know if you understand my idea. I will explain it in Vietnamese. Bạn, đây là cái cách chung mà mình không biết mình nói các bạn có hiểu không? Đây là cái cách chung để bạn trình bày một vấn đề mới, đúng không? Trình bày một vấn đề mới, đầu tiên là phải nói cái này nó mới ở chỗ nào, nó khác với cái cũ ở chỗ nào, đúng không? Thì đây là cái bài toán có upper bound, thì bạn chỉ giải thích cho mình là cái này nó khác với bài toán cũ là có cái upper bound. Upper bound là gì, đúng không? Ví dụ như UAB bằng 10 là gì? Tức là cái capacity maximum, đúng không? Mà ta có thể di chuyển ở trên đó tối đa là 10 đơn vị. Anh có thể di chuyển dưới 10 đơn vị ok, nhưng mà trên 10 đơn vị thì không được, đúng không? Cái CA là chỉ được 80 thôi, mà move hay hơn 80 là không được. Đó là cái khác, đúng không? Bây giờ bạn qua cái algorithm. Trước khi làm algorithm thì là phải có một cái tree solution. Is that okay? Feasible tree solution. Nhưng mà bình thường không có upper bound á, thì trong lecture note từ bài các bạn tìm cái feasible tree solution rồi, đúng không? Thế nhưng mà cái bài toán này nó mới. Trước khi mà làm algorithm là phải tìm cái feasible tree solution. Bạn tìm thử thì cái cách tìm này nó có giống cách tìm kia không chứ. Chưa tìm được cái tree feasible solution thì không có làm lời giải được, không có làm algorithm được, thuật toán được. Vì cái thuật toán là phải bắt đầu từ một cái feasible tree solution. Understand? Từ cái đây, cái bài toán đầu tiên này, cái hình thứ nhất này, cái hình bên trái này. Bây giờ các bạn chỉ ra thử đi, lấy có viết được không? Có viết được là như mình viết không?
Dạ được thầy.
Vẽ lên thử coi cái feasible tree solution như thế nào. Vẽ cái coi.
Dạ thôi thầy, ý là khoan. Dạ tụi em có một cái ví dụ phía sau lưng luôn á thầy. Cái sau lưng nó có một cái ví dụ luôn để có thể nói được cái đó luôn á thầy.
cái thí dụ, nhưng mà cái thí dụ của bạn mà mình không biết, tức là ở đây là từ A tới B, mà trong cái thí dụ của bạn là từ B tới A, thí dụ như đó, đâu có giống cái bài này. Dở lại mà coi, đây đó, quay lưu lại chỗ nào hồi nãy đó, chỗ hồi nãy đó.
Dạ, đây ý là có một cái application, có một cái example về cái bài này luôn á thầy, nên để em nói luôn phần này được không thầy?
Mình không biết, nhưng mà cứ đầu tiên trước khi vào algorithm là bạn phải tìm một cái feasible, initial feasible tree solution. Ok,
Yes. Okay.
này cũng được rồi. Cái này feasible tree solution đâu?
Dạ thầy. Yeah, yes. Yes, this is when using the upper bound technique to solve this initial. Wait a moment, please. We consider the minimum cost flow problem to show below, where the BI values are given by the node, the Cij values are given by the arcs, and the finite Uij values are given in the parentheses by the arcs. Obtain the initial basic feasible solution by solving the feasible spanning tree with the basic arcs, A to C, B to A, C to D, and C to E, where one of the non-basic arc R is D to A is reverse arc.
No, you have to write on this figure or draw the figure in the next, because you say like this, people quite hard to understand.
Oh.
I don't know what is it. It's better to come back to the, because this is quite different from the first figure. So you just come back to the first figure and you draw the basic arc. I don't know why the first is -6, you know. Here, look. Okay, here is from A to B. The arrow is from A to B, not from B to A, and the cost is 6, not -6. So why you come from here to the next figure? Why is it? I just asked you to show us an initial feasible tree solution. Do not do anything, you know?
Okay. When using the upper bound technique to solve the initial spanning tree in this problem, we let D to A be the reverse arc. It means that the beginning we let AD be the living variable by letting it reach the upper bound UAD equal 40. Then the network flow is in the figure on the left.
I just asked you to give us the initial feasible tree solution. That's all. This group is okay. So this group stop, and this presentation is 25 marks. Is that okay? I give you only 5 marks. If you want to improve it, you have to prepare it again. And next week, I give you half an hour to speak again. Okay? If you don't want to take only 1 mark, you have to improve it.
Okay, sir.
Okay? Next week. But prepare carefully. Is that okay? Understand very clearly. Okay? You have 2 weeks already, remember. Okay. The group 3, the same problem. The members in the group 3, just a moment. All the members of in the group 3 need to open the camera. Group 3 including Tường Vi, Phương Thi, Thanh Trúc, Hà Uyên, and Nguyễn Vinh. Okay, this is group 3. So you choose one. Just only 4 students, one more.
We have Tường Vi.
Tường Vi is absent. Okay, you are there. Okay, thank you. So what is your choice? Who will talk in your group? What? Who? The first one. You can discuss.
Mì Nguyễn Vinh ạ.
Nguyễn Vinh, okay. So Nguyễn Vinh is okay, and Nguyễn Vinh. Nguyễn Vinh, where are Nguyễn Vinh? Nguyễn Vinh, yeah. Did you? So it means that you that's only you is a boy. Another one, Phương Thi.
Yes.
Okay. And so I choose Thanh Trúc is one. Thanh Trúc and Hà Uyên. Okay. So you can discuss to each other, and you can choose the order. 1, 2, 3. Who's the first? 1, 2, 3. And the time now is 14:05. And you also have 45 minutes. Hà Uyên and Thanh Trúc in the same place. That okay, no problem. If you don't afraid of COVID, then no problem. Okay, who is first? Quick. So among the three. Okay. Okay, who is the first? Hello? It sounds that you say something, but I don't hear it.
Hello, can you hear me?
Yeah. So who is the first?
So I'm Hà Uyên. I'm Hà Uyên.
Pardon? Hà Uyên first. Is that right? And then who is the second? Trúc or Vinh? So be careful. Your mic is not quite stable. Ah. Sometimes we hear it, sometimes not. Not now. No. So what? The mic has some problem.
So hello, can you hear me?
Yes.
Okay. So I will be the first, and Thanh Trúc will be the second, and the final one it will be Vinh.
Okay. Okay. So first.
Yes. Good afternoon, everyone. We are group 3, and we will present about the problem 1, which is network simplex method. We will use incorporate the upper bound technique. So our group has five members, which are Tường Vi, Phương Thi, Thanh Trúc, Hà Uyên, and Vinh. So now we move to the main part. As you already learned about the terminologies of a network, we will skip it and just move on to the next part, which is upper power technique, and it is a smaller one in it, that which is a reverse arc. Now I will talk about the upper power technique. So So by addressing minimal cost flow issues, the network simplex approach is a more simplified variant of the simplex method. So as a result, in order to go from the current basic feasible solution to a better nearby one, it repeats the same fundamental procedures at each iteration. Finding finding the entering basic variable, identifying the departing basic variable, and solving for the new basic feasible solution. And by doing that, we will lift up several elements that are required for a complete computer implementation, such as how to build an initial basic feasible solution and how to conduct specific computations, such as determining the entering basic variables is the most efficient way. So the first concept is to incorporate the upper bound technique, which was described to deal with the arc capacity constraint efficiently. The capacity constraint is the lower bound or upper bound, and here we only mention the upper bound, which is xij less than or equal to uij, where uij is the upper bound of the basic arc. This is the maximum capacity that the arc ij can move or transfer from node I to node j. And meanwhile, that Cij is the cost of when we transfer one unit from node I to node J. For example, right here in the by the arc AD, the CAD is 9, so that it will cost 9 to move one unit from node A to node D.
Very sorry.
Yes.
Is it exactly the problem you consider at the beginning?
Yes, we will consider the figure 9.12 later when we will solve it.
No, just a moment. You move back to the initial problem. Here, is that right? So, sorry, I have something to I do something here. So I don't understand how you change from here, from AB to BA, and from 2 to -2 there. Say it again.
So 2 is a cost when we move one unit from node A to node B, and by the upper bound technique that after that we will consider deeper in the reverse arc. This is a smaller technique in the upper bound technique. So we will replace the arc AB to into the by the arc BA, and so since 2 is a cost to move one unit from node A to node B, now we transfer from node A to node B to node A, so the cost will be -2. Is it reasonable to you?
But I don't know how you talk about it. At the beginning, why you move A to B, and why you move back to B to A? I don't understand. So start with this problem. Then what do you do first? We have this problem, and what will we do first?
We consider the constraint of the.
Ian, why you turn off your camera? It's not clear when you turn on the micro the camera.
Oh, my mistake. I'm sorry.
Okay.
I didn't realize. Yeah. So first, we have some capacity constraints, which is upper bound of the arc capacity. Here we can see that we have UAB, UCE, and UAD. So that is maximum.
No, not UAD. Do we have UAD?
Oh no, I mistaken. So yeah, we have here we have yeah. We are talking about the U. So there are UAB equal to 10 and UCE equal to 80. So that will be the things that we work on to get optimal solution efficiently.
Excuse me. We go back to you understand? Do you know why it is upper bound? Why it's called upper bound? Why? Well, this number is called upper bound.
Upper bound is the maximum capacity that the arc can move from node, for example, like node AB. So it's the maximum capacity that where the node A can move to node B.
Why they don't call the right bound or the left bound or lower bound or something, but it is the upper bound. Why?
So upper bound is about, okay. So that will the thing that prevents you to go further, and it's not lower than the maximum. So the max, so is of course is upper bound. We already learned a bit about it from analysis 1. So it's just called upper bound because it is a maximum that we can reach.
But so you understand what are there up to you what you know? There is something like a lower bound or just only upper bound?
So as we can know that there does exist lower bound, but we don't discuss it further. We only
lower bound means something.
So I think lower bound is maybe I think it's usually is equal to 0, and lower bound is list. Is a list that one node from like arc AG, like from I, it had to move or transfer at least that much to node J. I think so.
It is very easy. You know that because you just say you don't write down anything. You must write and then you will see. X, for example, you have Xij less than Uij. Is it okay? Xij, for example, in this case, Xab is always less than Uab. So this is called the upper bound. You see, the set is bounded above. Is that okay? So that
Yes.
Upper bound. It is bound on the upper, on the above, you know. And the lower bound is Xij greater than something. You understand? Greater than 10, greater than 9, greater than 5. For example, here you may have Xab less than 10, but for example, if you have a lower bound is greater than 3. You understand? So that means that in that arc, if you want to move, you have to move more than 3. Cannot be less than 3. Is that okay? And so that is called lower bound. But here, of course, you consider upper bound. I just want to ask you because you always say upper bound, but I don't know if you really understand what does it mean upper bound or not. Okay, so now we have the 2 upper bound in 2 arcs here. And then what do we do now, Ian? What do you do first on this?
So we just let me wait for me a little bit.
You got this problem. You are facing with this problem. So what do you do first? Starting, if you start to use the algorithm, like at the other team, the group one tell you that okay, before find out an initial feasible tree solution. Is that right? Without initial feasible tree solution, you cannot do anything. You can start the algorithm. So first of all, initial feasible tree solution. How can you find it? The
So yes, yes, yes.
so what you say?
I just wanna talk about more about the reverse arc to be more clearly. So an important remark about the reverse arc is why the network simplex method is when it's generating a sequence of basic feasible solutions. We suppose that we suppose that xij has become the living basic variable for some iteration
Just a
by
moment. You suppose what?
suppose that xij means the
Ij.
capacity
No. Where is Xij? You suppose
xij.
just any Ij. Okay. Any
Yeah,
Ij.
yes,
Then
ij is in the tree solution.
but what is the initial tree solution here? I don't know.
So as you can see here, like, away from me a little bit because
Here is not you do like this. It's quite hard for us to understand. You have the network, and you have two figures in one slide. You know, one is initial network, another one is a feasible solution. So we can compare. But for example, at the beginning, at the problem at the beginning, A is 50. A is the supply node, and it's 50, not 40. So why here is 40? You see? And B is 40. And now B is 50. Why? Not reasonable. So you have to explain. So you see, it's not easy to teach people. Even you understand, but to teach people to understand what exactly the same like you understand, not easy. Okay. The method to say, okay, you, the people in the group, you can intervene to say, you don't need to ask my permission. You understand? You are a team and you talk to people. You have the right to say, okay, so Nguyễn Vinh, don't ask my permission. Is that right? If you want to say, you just say. Hello, Vinh. Want to say? You want to explain something?
Yes, I will explain the problem.
Okay, that's good.
Can you see my slide, teacher?
Yes.
Here's the first. Here's the feasible solution.
No,
And
this is the problem.
yes, the problem, the original problem.
Yes.
And we consider that XAB will be the non-basic variable and the living arc.
Why is non-basic variable? Basic variable or non-basic variable?
Non-basic variable. We consider that. We consider that, and after some iteration, we also find that CE
No.
will be
You
the
don't
non.
understand. Vinh, you don't understand. You have a problem. And whenever you have not yet do anything, each arc have the equal level. None of them is a basic variable. None of them is non-basic variable. They are all arcs, normal arcs, nothing else. Now, if you choose a tree, you understand? If you choose a spanning tree as an initial feasible solution, so any arcs in that tree is basic. The arc which is not in that tree is non-basic. You understand? When you choose a tree solution, then you have, after that you have basic and non-basic. But at the beginning, you have a problem, and all the arc are just arc, not basic anything. No anything. That's when at the beginning you didn't do anything, so nothing is arc.
Yeah.
You cannot say AB is non-basic, basic, or something like this. So what we do first?
Yes. Here you see the UAB is 10.
Yes, UAB is 10. So that
Yes,
means
so we move 10 from A. 10 from A to B.
why?
That's
Why certainly you move that? Why didn't move from C to E?
because I apply the upper bound technique for XAB. And
Upper bound
XAB,
for up IB? No, it's not really reasonable. Why certainly you move from A to B? I don't know. You move to the next slide. No.
is
Here.
the adjust network. After moving from A to B and the reverse axis will be the BA and the cost will be -2.
No, but you come to the, what is your basic, what you call basic
Yeah.
feasible solution?
Here is my basic feasible
Here.
solution. Yeah.
Okay, so let me check the initial 50.
Yeah.
Yes, this.
Yes.
You choose this, and then what
Yes.
do you do?
Then I will
No.
so
Just keep there. Okay.
okay.
Let I tell you.
Yeah.
Let me tell you. Okay. You choose this as a spanning tree. Is that okay?
Yes.
And you want this to be the basic feasible solution. Is that right?
Yes.
But at the beginning, you come to A and you write down A at the beginning is 50. You change it to 50. And tell me, what do you do? 50.
Because AB is a reverse axis.
Why?
Oh, we are
It's
given that.
you
We are
know,
given that AB is a reverse axis.
I couldn't understand why suddenly you do like this. Suppose you come back to the problem. Here. Suppose I write down AC, UAC. Suppose that AC also has upper bound. Is that okay? And UAC is 15. Then how do you do? You also make the reverse AC to CA. You make the reverse of all of the arc with the upper bound. Why? Why suddenly you do with AB? I don't know. Understand, Vin? Suppose that we have 3 or 4 arcs with the U, with the upper bound. UAB, UAC, UCE, for example, DE.
But
And then
we are
all
given that AB is a reverse axis, not AC, AD, or IE. Just AB is a reverse axis. Okay?
I got. So you see, you mean
Yeah.
that CE is not reverse?
No, because we are given that. Not we consider. We are given that AB is a reverse axis.
Where is it? I don't know. Where in the book they write down like that?
Yes, in the book, page 439. Oh,
Show
38.
us. Show us. Actually, CE also reverse, you know. Any arcs with the upper bow can be reversed. Not only
Yes.
this one.
Yes, and I said before, now I consider AB first, and after some iteration, I will find out that CE also reverse. I said before.
So okay, I tell you why you choose AB, not CE. Why you choose first? Not reasonable. If I have AC, it's also the arc with the upper bound. So which one you can choose? No. Uh,
Can you see my share screen?
yes. So where is it?
Here, I just consider AB become a living basic variables.
Where is it? Page you say page 400? What?
48, the 38.
438. That is the place where you expand it to be bigger. Just do not say the page 339. Yeah, open it more and then okay, show us. So what do you say? What is here? Okay, let me share your screen, your slides, and then I tell you. Okay? You have anything to say right now?
Here is the problem we are given.
Okay, Vin, let me tell you. Yeah, I will upload I will share the screen and then I will show you. Say, look, your slide is here. You have the problem. This, is that okay? No. This, is that okay? And now you choose like this. You choose the no, I make it in red. So you choose A, from A to D. Is that okay? From D to E here. This. From C to E, like this. And from B to like this. Is that okay? This is the initial feasible tree solution you choose. Here, in the next slide.
Yes, it's my
There's you.
basic feasible solution.
Okay. And I don't know why it's 40, but at the beginning, this is 50, and this is 40. Is that okay? At the beginning, it is this. And you change to 40. Okay, you change to 40, and you move from, you change to 40. So I write it in blue. You change to 40, and then this is 40. You change to 50. You change to 50. Is that okay? And you move here, 50 here. But here they, you change to what? You change to 40. Sorry. What you change here? You change to this. Is that okay? So because you change to this, here you move here 40, and this they need 30, so they still have 10. Is that okay? You move 10 here, 10 along this, and 50 you move here 50, but here they don't need anything, so you move all 50 here, and then you have 50 and 160, and this they need 60, and that's all. Is that what you do?
Yes.
Is that okay?
Yes.
Okay. So now I do it like this. At the beginning, you say, okay, I delete all of your thing. I delete all your thing here. At the beginning, it is 50 here, and here is 40. Is that okay? So I move like this. I move 50 here. Is that okay? And still here have 20. So I move 20 here. And I have 40 here. I move 40 here. And they need nothing. I move 40 here. And that is also 60. Everything is okay. So why did you change to 40, 50, AB, you move and you change it? He said, I don't understand. And this it does not violate any rules here. Is that okay? Because UCE is 80, but I moved just only 40. UBC, no up about. So UBC, I move 40, that is okay. And AB, BA, I don't move anything on that. And from A to D, I move 50, then everything is okay. So why not like this? Why you make something at the beginning there? I don't understand. Everything, this is okay. This is the initial feasible tree solution. I suppose this. Listen. Suppose here. I delete all the 50 of you. Here. I suppose it's Vin. I suppose that at this they write down U. Oh my God. UCE is just 40. Yes. If it's just 40. Just 40. And then if you don't change. No, at the beginning, what is it? At the beginning, no. At the beginning is 40. Suppose no. Let me show you. At the beginning, look, I delete all this, and I tell you, we chose this, and at the beginning, suppose that you have this UAD is at the beginning. You have here 50. You have here 50, and you have here 40. Is that okay? Suppose that at the beginning they have here UAD is 40. Then you cannot move all the 50 from here to here. Is that right? When you understand? If
Yes.
If UAD is bounded by 40, then you cannot move all the 50 to this. You need to move 10 to here. Is that okay? And when we move 10 to here, then you cannot move it anymore, and then it become converse. And then C equal -2. Is that okay? And here is 40, and here is become 50. Then everything is okay. I agree with you. And we don't put this anymore. And it is the same like you. It is 40, and then it is 10, and then you have 50, 50, 50, and then that's 60. Then everything is okay. Then I agree. But we don't have any like this, so you can move all the 50 here. So why you suddenly you move from A to B? Hello, the members in the group, you can answer. You have to think and reasonably. Is that okay? You have to start from the beginning this problem, so you do step by step. Is that okay? This group, you spent 4:05, but it's 4:35, so you almost 45 minutes, but you cannot overcome the first step, the initial feasible solution. So the other members in the group, hello. Now is we have 45 minutes, so we stop. This group also stop. And you also have 5 points, 5 marks as the group 1. And you can improve it by consider it again. Is that okay? Understand clearly, and next week you also have 30 minutes to improve your marks. Okay? You can forget the improvement next week. You accept. I accept 5 marks. Then it's okay. But if you want to have more, you have to work again in the group. Is that okay? And try to understand step by step. So I say to both the group 1, 3, like this. Okay, I say in Vietnamese. Rất là đơn giản, nhiệm vụ các bạn rất đơn giản. Đây là cái bài toán network flow problem, không? Nhưng mà nó chỉ thêm một tí thôi. Nó giống y như những cái điều mà các bạn học ở đây sau này. Thí dụ các bạn học ở đây là giống như bài giảng của tôi giảng, đúng không? Nhưng mà khi các bạn ra đời các bạn gặp cái bài toán như này, nó có thêm cái upper bound, nó có thêm cái nó, thì mình làm thế nào, đúng không? Đó là cách để mình giải quyết những cái chuyện khi mình học là A thôi, nhưng mà khi ra đời các bạn gặp các cái mô hình đó, nó không phải là A, nó không phải chính xác y như nữa để mình làm. Nó khác đôi chút đúng không? Nhưng mà nó khác thì mình phải modify cái phương pháp của mình như thế nào để mình giải. Thì những cái như này là những cái để giúp cho các bạn phải suy nghĩ đúng không? Nó khác với bài giảng của mình thì mình làm sao? Cho nên là cái nhiệm vụ chính của các bạn trong mấy cái này là chỉ là gì? Cái bài toán này nó khác với cái bài toán trong lecture notes mà thầy giảng như thế nào, chỉ ra cái chỗ khác. Nó khác như thế thì cái phương pháp giải, cái algorithm là bên kia nó như thế. Bây giờ mình modify cái algorithm đó như thế nào, chỉ cứ đó thôi. Các bạn chưa vượt qua cái bước đầu tiên, tức là gì? Cái bài toán cũ á, không có upper bound á, thì ta tìm cái initial feasible solution như cái phương pháp mà tôi dạy đúng không? Như phương pháp trong sách. Ok. Bây giờ bài toán có upper bound thì tìm cái initial feasible solution như thế nào? Có khác gì không? Bước thứ nhất tìm cái initial feasible. Bước thứ hai mới tới algorithm đúng không? Algorithm thì thí dụ những bước 1, bước 2 như mấy bạn hồi nãy trình bày không cần, tức là các bạn chỉ nói qua là bước 1 làm y như cũ, bước 2 tính C ngang AB với lại C ngang của EG với EG là không thuộc T y như cũ. Bước 3 thế nào thế kia, nếu C EG mà âm thì cái gì y như cũ. Đó. Nếu như mà nó dương thì thế nào thế kia. Cái gì y như cũ thì cứ nói y như cũ, đúng không? Còn cái gì mà tới cái chỗ này là thay đổi nè, không? Vì nó có upper bound cho nên là chỗ này không làm được như thế được, thấy chưa? Phải là chuyện thế nào thế kia, chỉ có thế thôi. Understand? Vì cái này mình nghĩ là nó lạ cho nên là mình mới cho hai tổ, không, hai group làm. Nhưng mà các bạn không hiểu gì cả, các bạn hoặc là các bạn không có đầu tư thời gian để mà ngồi với nhau mà tranh luận mà tìm hiểu gì cả. Các bạn cứ lấy sách cứ viết ra, trong sách nó viết thế nào thế kia, không hiểu gì cả, không được. Sau này á, cái gì những cái thuyết trình này á, các bạn nhớ là cái chương trình mình nó có cái gọi là program learning outcome, không? Nó có 11 cái program learning outcome. Trong đó nó có những cái này là có những cái learning outcome, tức là những cái mà mục tiêu á, là bắt các bạn phải đọc tài liệu, phải hiểu đúng không, và phải sử dụng được những kiến thức mà đã học, modify được những kiến thức đã học vào trong cái điều kiện khác biệt của thực tế. Một trong những cái yêu cầu là như yêu cầu thứ hai là phải nó tạo cái develop cho các bạn cái khả năng là học tập suốt đời, không? Mình học cái này rồi nhưng mà ra trường nó gặp những cái khác là mình làm răng. Mình phải đọc tài liệu đúng không, mình phải tìm hiểu, mình phải đọc, mình phải hiểu từng tí như thế để mình học cái mới. Thì những cái bài thuyết trình kiểu này là đáp ứng các cái yêu cầu như thế của cái learning outcome của cái chương trình ấy chung ấy, mà nó cũng là của cái môn này nữa hả? Phải thực hiện cho đúng cho được mới đạt yêu cầu. Như này không được đạt yêu cầu, không đạt yêu cầu, đúng không? Hoặc là các bạn lơ mơ nghĩ là cái này nó dễ là không có chú ý, hoặc là mình không có thảo luận kỹ, không? Mình tưởng mình hiểu nhưng mà hóa ra mình không hiểu. Các bạn phải xúm lại với nhau, đặt câu hỏi qua hỏi về, đúng không? Người này không hiểu thì hỏi người kia, mà phải, nếu mà cả tổ không ai hiểu hết thì phải tập trung lại mà tìm hiểu mà trả lời cho được. Ok, cái này sẽ là cái bài giảng cho các bạn khác học á hả? Tuần sau là hết hạn rồi đấy, tuần sau nữa là thi rồi đấy hả? Ok. But this group is you are okay because your slide you prepare is very nice. I don't know how you make the color in inside is okay. Inside I can make it, but you make the color at the in the border, the end or the something like this. So I would like to have your test. You prepare it by test. Is that right? Is that right?
Dạ đúng rồi thầy.
Okay, so can you give me the test file?
Dạ, em làm trên Overleaf á thầy, là em share mail hay là em
Overleaf ở trên mạng hả?
dạ đúng rồi, cái LaTeX online á, em có gì thầy có cái em share cho thầy.
Mình không có cái đó, nhưng mà bạn không load được cái file text xuống à?
Vậy để em download về rồi em gửi mail cho thầy nha.
Rồi đâu rồi, gửi mail cho mình chỉ cần nó có mấy cái lệnh thôi mà.
Dạ
Tức là
dạ.
của bạn là giống của mình, chỉ có cái đầu đề của bạn làm màu xanh màu đỏ là mình thấy nó cũng được rồi. Mình có thể mình đổi màu khác, nhưng mà làm màu thì nó hấp dẫn hơn, không?
Dạ có gì
Okay,
để
okay.
em gửi mail cho thầy nha thầy.
Okay, thank you.
Dạ.
Thank you. So maybe we will consider continue next week. Okay? Try to prepare and to understand it, and talk next week. So the group 2, where are you?
We here.
Okay, turn on your mic. Turn on your mic. Turn on your camera. Hello.
Yes, we are here.
Okay, the group 2, you choose one. Group 2 including Trà My, Minh Quân, Anh Thư, Minh Thư, and Hồ Thương. Is that right? You choose one.
Yes, sir. We chose Hoài Thương.
You choose Hoài Thương. Okay. And let me see. Hoàng Trà My, Minh Quân, Anh Thư, Minh Thư, Hoài Thương. See somebody very handsome there? Okay, there's only one boy. Handsome boy. You are? Minh Quân, is that right?
Yes, sir.
Okay, so I choose Minh Quân. And another girl. Another girl. Anh Thư, Minh Thư, Trà My. Okay, Trà My, where are you? Trà My, where are you?
Yes, sir. Yes.
You are there. Okay. But I tell you, any of you in the group, if you don't, if you can answer the question or you want to say something, you just say. Is that okay? All of the member in the group. Okay. So who will start talk first? You choose.
Me, Hoài Thương. I will talk first.
Họ Thương, and then the second.
Second will be me.
Will be Minh Quân.
Okay. Minh Quân, and the last one is Trà My. Is that right?
Yes, sir.
Okay, so you start at 14:55. So you work to the end of the class. Is that okay?
Okay, I will present now, sir.
Yeah, okay.
Okay. Hello, my name is Thương. Today our group will present the minimum spending trees problem. Our group including five members: Nguyễn Minh Quân, Hoàng Trà My, Nguyễn Anh Thư, Nguyễn Thị Minh Thư, and me, Hoài Thương. Our presentation include five parts. First, I'm gonna introduce the problem that we're gonna apply the minimum spending tree. This is the draft of the road system of Sivada Park. The park wants to install the telephone line under the road to communication. Therefore, the Sivada Park management needs to design the telecommunication network that connect all the network with the minimum total length of line. As we can see from the graph, that there are north and distance with the thin line, and these thin lines here to present.
What you say, team line? What? The notes are what? Sorry, I don't hear clearly. You have to say a bit more clearly. You say
Thin lines, the line connect to each two station, like AB.
okay, the line connected to
Yeah.
that is okay.
It's a line.
Yeah.
Okay. Okay. And okay, before going to find the solution for this problem, we are going through the general setting and the algorithm to construct a minimum spending tree. Next, Mr. Wong will present the dream algorithm to construct the minimum spending tree.
Can you see my slide now, sir?
Yes. You should ask your friend in the class.
Can everyone see my screen now?
Yes, I can see your screen.
Okay. So Thương has already introduced the introductory example from which the concept of the minimum spending tree problem arises. And so I will now present the problem of finding the minimum spending tree in its very general form. So generally, we consider an undirected and connected network G with the set of nodes N and the set of ops A, and we also call these up the potential links. And this problem is different from the problem that the professor didn't provide us in the class, the minimum cost flow problem. That in this problem we do not consider any supply or demand associated to nodes. Rather than that, we will consider the length of each arc. So each arc in this undirected connected network will be associated with a value xij, which is positive, and we call it the length of the arc. And and our goal in this problem is to find a spending tree T, which is a connected cycle subnetwork that linking all nodes in the given graph G, such that the total arc length of this tree must be the minimal, which is why this problem is called the minimum spanning tree. And I denoted the function LT here denote the sum of the lengths of all arcs in the given tree. So that is our goal. We are given a graph and we want to find a minimum spanning tree on that graph.
Okay.
And
so let's why spanning tree?
Do you mean that spanning tree but not the spanning graph, or?
You mean I mean here what we try to find a spanning tree. Why spanning tree?
Because in the initial problem we want to the park operator, they want to connect to ensure that all pair of stations are pairwise connected by a telephone communication lines. So which means that the set of arcs that we select here must connect all nodes pairwise. But we also notice that because if we have we say a cycle in the set of arcs that we select, then we can drop one bit away.
Because we need to connect all the station. Is that okay? So it should be spanning tree. Spanning tree means that the tree that include all the nodes. And so here all the station. That is okay. Okay, thank you.
The idea here is that we do not need to select all the edge. We just need to select the minimal amount needed. And we have already provided the problem in its general form, and now we will our group will present an algorithm that are used to solve this problem, which is included in the book, and the algorithm is due to Prim. And it proceeds as follows. So first we will have to choose an initial starting node to start the algorithm, and we will for this algorithm, its advantage is very relaxed in the sense that we can pick any node in the graph to start without any restriction. And and therefore our initial tree will consist of only one node that we selected for starting the algorithm, but without any arc yet. And then we will proceed to add arc and nodes to this tree to complete it and yield an optimal tree solution. So in step 2, we check whether this tree already contains all the nodes in the provided graph. If it is, then the algorithm stops with the optimal total arc length is the length of the current tree. Otherwise, then it means that there are some nodes in the tree that we haven't included in this. There are some nodes in the graph that we haven't included in the tree yet, and then we have to proceed to include such nodes. And the idea to include.
I want to ask you something. In the step 2, if n prime equal n, and the algorithm is stopped, so what is the optimal things?
So you mean that if starts at step 1 and immediately stop at step 2?
Yes.
So it means that it is a very special case. So the graph only have one node I, and we have nothing to connect. So the optimal length will be 0.
That is okay. But you should ask. You have to explain clearly. Is that okay? I don't know if the other people understand.
Okay, I will notice that.
In that case, there's only one station. Is that okay?
Yeah.
You don't need to connect to anything, and because so in that case the set of arc is empty. You don't connect to anything, and the length is what?
The length is 0 because we don't use anything.
Nothing. The length is 0. The optimal is just one node, and the length is 0. Is that okay? So okay, continue. Just for fun. Okay, continue.
So the method that we use to add a node to the current tree is that we consider all the nodes that are not included in the tree yet. Then we consider the distance from that node to the tree, and we choose the arc that is closest to some node in the current tree, in the sense that we consider all edge which include one node, which connect one node that is already in the tree and one that is not in the tree yet, and we consider all such arcs, and we select the one with the minimal length, and we will add that arc to the current tree. And so that is the idea. And maybe there are several cases that there are multiple arcs that are of the same minimal length that can be added to the tree. Then we can choose any one of them. And the last step is to update the new tree, which means that we include the arc that we choose in step 3 and the node of that arc that not already in that tree. So we add it to the current tree. And here is the the setup nodes will be presented with one more node, the node J0, and the setup arc will be included with the arc I0 J0 that we selected in the previous step. And then we return to step 2. That means that we restart the iteration again with this updated new tree. So in WORST, the PRIMS algorithm, it starts at any node of the initial graph, and then it keeps adding the closest unselected node that is accessible from the old nodes to the tree until the algorithm stops. And one more information about this is that if the tree has n nodes, then the algorithm, the graph has n nodes, then the algorithm will stop after precisely n-1 iteration. And so maybe people will look at this and see that it is quite complicated and hard to understand. So our team member me will apply this algorithm to the introductory example that our team has.
Just a moment. The algorithm here sounds okay. Anyway, we can understand. But where is the stop of the algorithm?
Yeah, it is at step 2. If we add the app and the node at an iteration, then we have to return to step 2 to check for the new tree. So the breakout will be here. So if the tree includes all the nodes of the initial network, which means that it already spans the network, then the algorithm will stop with the optimal total arc length is the length of the current tree.
First of all, you have not yet defined the total length LT is what?
Yeah, I give it in the general setting section already. It is the sum of all the arc length of the current tree. I have defined the function here.
Back to the algorithm. It sounds to me something not quite clear. Okay, let it there. If you can imagine, algorithm is something. What you say about algorithm means you will work, you will supply something for the machine. Is that okay? Suppose that if you use some kind of language like a C, like any kind of language to program.
Yes.
And then it should be not quite clear, because you see, update the new tree, you have T-bar, you know? You have T-bar, but the T-bar is N prime and N prime union with J. A prime is A prime union with
the new arc. With the new arc.
G0. That is okay. But you say return to step 2. To step 2, then N prime equal N. But here you don't have N prime and union with.
I think that we should.
To tell to the machine, what do you do now?
So I will set the N prime equal to N prime at G0.
Yeah, that's right.
Yeah.
You should do like this. Is that okay? You
so
said
I should write it more clear.
More clear. N prime equal set up like this, and then turn back to the step 2, and then yeah, because the L and the T, you know, because you in the step 2 you calculate the length LT, you know.
Yes.
So you let T bar exist and then set T equal
T bar. Yeah.
Then come back to the set 2. Is that okay? It should be quite clear.
Yeah, I see. So I should prepare it more carefully.
Yeah, okay. So you have to ask your friends if they understand. They have any question to ask your group.
Yes. Everyone in the class, do you have any question to me about the algorithm, or you may want to listen to the application of it on the introductory problem to understand more, or maybe then if anyone has question, please ask.
Student, you yeah, Minh Quân, you the group you make presentation, you should know that the how you say, the audience is the class, not me. Okay, and the student in the class, you have to understand that clearly. You have to realize really that this is for you, and you need to understand clearly. You understand? Need to understand clearly in order to work with. For example, I in the midterm is just something like an example, like an exercise, no problem. But for example, in the future, you have some problems similar like this. You need to understand clearly now in order to work on it. That okay? And okay, of course, in the next 2 months, next 2 weeks, if in the midterm exam, there is a problem with the tree, and I ask you find out spanning tree, you need to understand how to work on it. Okay, and find out the spanning tree, shortest spanning tree. That is quite easy. Okay, continue.
Okay. So now my teammate me will present the application of this algorithm on the given introductory example, so everyone can understand more about the Prim's algorithm and the problem.
My name is Jeremy, and now I will show you how to construct the minimum spending tree for telephone lines in the Sivadar part as an example for you to understand clearly.
Your mic has some problem. It's not quite clear, your voice. Anything?
Wait for me, sir.
Yeah, maybe should change something.
Can you hear me well, sir?
Yeah, continue.
Yeah, my name is Jeremy, and now I will show you how to construct the minimum spending tree for telephone lines in the Sivadar part as an example for you to understand clearly about the algorithm. As we said in the algorithm, in step 1, we first construct an initial tree by taking an arbitrary, not O here. I will set up the initial tree T0 now includes not O and there are no arcs. Since there is only one not O in the set n prime, which does not equal the set n. So we gonna go to the next step, step 2. Among the unselected nodes, we can access to node A, B, and C from O. And here where the length of OC is 4, OB is 5, and OA is 2, which is the smallest value. So we can choose the node A to generate an arc for the tree.
Just a moment. Trami, you normally when we are talking with people, whenever you say some terminology which is new,
Yeah.
you have to explain. So now, for example, what you say, not connected node or something, or some words you say what not connected nodes or something like this. So what are not connected nodes? Is that what you use? Not selected node or not connected node or something like this. You use some words like this, and you need to explain.
There are not that are not included yet, not include in the current tree yet, sir.
So you have to tell us current tree. You use any words you use which is new. You have to explain. Current tree means what?
Current tree now is T0, and T0 has not O, and there are no arc that I mentioned.
Yeah, it's okay. Now at the beginning it's not O, but when you do something already, and then the tree you get at that time, is that okay? You also call it a current tree, okay? Okay, continue. I just just to remind you that okay, when you talk to people something new, you have to explain. That's all. In principle.
Thank you, sir. Okay. After having the knot and arc, we gonna update to the new tree, which now include the set of knot O and A. And the set of arc now include one arc OA.
So can you explain again why you choose knot A? You have to write down something.
Because among the knot A, B, C that are accessible to knot O, OA has the smallest arc. So we choose the knot A to generate an arc for the tree. Is this okay, sir?
You have to ask your. Let me check. The step. You look at the step. You explain the step tree. Now you choose A. You choose A by using the step tree. Is that right? So you come to step tree. Back to the here. The step tree. Step tree means what? Now you find a node. Find a node in n minus n prime. Is that okay?
Yeah.
That node have a what condition? That node have one condition. In this case, n prime is only O. Is that okay? N prime is only not O. And so the minimum here, just minimum X O to some others. Is that okay?
Can I have her answer your question?
Yeah, that's right. You can explain here clearly a bit more.
Okay. We in the step 3 we choose the node in the set A minus n ram. So the all possible node J0 in here is A, B, C, D, E, and T. But there is only 3 nodes A, B, and C that is accessible to the node O. We cannot connect directly from node O to node D or node O to node E or node T. So we just consider 3 nodes in here is A, B, and C.
No, they don't. You in the step 3, you see, come back in the step 3. No, they didn't say anything that node you connect from no, not a node on n prime to accessible. Then you say something accessible, but here don't have anything accessible. What is it? No.
Which means the mean value.
J not belong to n prime. That's all. Is that right?
Yes. Oh, yes, J0 is not belong to n prime.
Here, J is not belong to n prime. Just J belong to n minus n prime. And here that means J is not equal to 0. Not equal to not 0. Different from not 0. That's all. You didn't say here in the set tree anything accessible or something like this. No. So how can you explain now?
Okay, so for example, in here on Xij of us in here is the set of OI, the length of OI, OB, OC, OD, OE, and OT.
Yeah, that's right.
But as we can see that if we connect from node O to node A is to node B is 5, C is 4. And if we connect to D in here, we have some possible path to go from O to D. For example, I take OAD in here, it will be 9. From OE in here, I will go to OCE. This is 8.
But look. If you write like this, then you see, Mr. Minh Quân, you just look at your algorithm. You say, for example, OE. What is OE? Because in many ways you can go from OBE, OCE, but OADE. Is that okay? So what is OE? How can we define OE?
So am I answering it?
Yes.
So okay, so I think I will share my screen to explain it better. You can see my screen now.
Yes.
So we note that we recall the setting and the algorithm. So I consider the minimal arc to add to the algorithm at the iteration, but we first see what is the Xij defined. So I say that each arc Ij in the initial graph will be associated with a length, but in the given graph here there is no direct arc connecting O and C, for example. So of course O and C will not be a pair listed in the set, because Xij is only defined for the direct arc that already included in the initial graph that connect the node I and the node J. But here we do not have the direct arc connect O and C, so we don't consider OC for this set. So we only consider the node that already have an arc in the initial graph, that are OA, OB, and OC.
So something you write down in step 3, maybe you need to improve it. It's not quite
So I should include that it means that we only consider the nodes which have direct connection.
Now you have to include here something like Xij with I belong to n prime, J belong to this, so that Ij belong to A.
Yeah. So I can add it in that way. Yes.
And that you can say connected or something. What is some words you see? So any word you use, you need to explain. Is that okay? Connected nodes or something, I don't know, but exactly in this in the line in the step 3, you need to write out some more. Ij belong to A. Okay.
Yes. So ij should belong to the initial set of
To the
arcs.
set, yeah, the set of arcs.
I see.
That is okay. So you understand who is just talking? I don't know who is just talking there. You see, you have to understand very clearly. Do not explain by what you are thinking. Is that okay? We don't have a X A O E O D or something like this. No, we don't have that. We don't have O A O D. No. Hello.
Yes.
Yes, sir.
Okay. So continue. We have about 10 minutes more, so try to say quickly. So
And after, yes,
from O, you just only connect 3 points: OA, OB, OC. Is that okay? And so
yes.
that connect to that, you choose OA is shortest. So A is the next node. Is that okay? And now the set of n prime of U, including, you have to write down n prime now is equal to OA. Is that okay? Here, you set T1 OA. Yes, okay. You write down at the end already. N prime is OA. And then what do you do next? You come back to the step 2. Is that okay? And then what next?
And we go on considering the unselected nodes that are accessible from O and A, that are B, C, and D. There are 4 arcs we should consider consisting of OC with the length 4, OB with the length 5, and AD with the length 7, AB with the length 2. As we can see that AB is the arc that has the minimum length in this iteration. So the new tree now will be added by node B and arc AB. This is the T2 here. Since the set of nodes of the tree still do not equal the set n, so we continue to add nodes and arcs to the tree. We go back to the step 2 with iteration 3. We consider the unselected nodes that are accessible from O, A, and B. That are C, D, E. The eligible arcs are now AD, BD, BE, OC, and BC. And BC has the minimum length that equal 1. So we add node C
we also have the line OC. We also have to consider OC. Yeah, that one. And the minimum is BC.
Yes. So we add node C in the arc BC to the new tree T3. Here we do not consider OB in this case because O and B are already included in the tree already. So now our new tree includes not O, A, B, and C, and the arcs OA, AB, and BC. We can see that there still exists unconnected nodes, so the algorithm continue here. Just similarly, we move on to iteration 4. All possible arcs now are AD, BD, BE, and CE, where BE has the minimum length. Similarly, since the node O and C are both in the tree already, so we just ignore the arc OC. Now we update the new tree. The new tree will include the set of node O, A, B, C, and E, and the
Okay,
set of arc.
Tammy, you come back to the previous slide. Here. You say something which is not quite clear. We do not need to come back BO and BC, CO. That is not necessary. Why? Because in the step 2, we consider the nodes on n minus n prime, you know? And certainly the node OA or something is not in your choice. You understand? That's the first thing. It's not necessary to say. Another thing is, suppose that you write down a program using some kind of language, you know? To me, can you imagine? Suppose that you write down some language to tell to the machine, find out the nodes that is directly connected to the node in n prime. Then how can you write? How can you tell to the computer?
I think we check the initial graph and
no, you cannot say we. You have to tell to the machine. How can it find out some DE for you? How can they exclude T or something like this?
Oh.
Other member of the group can answer the question.
Can I answer it?
Yes.
So okay, so I think I can speak it without sharing. So if we want to check which node is connected to directly to A, for example, then we can consider the initial graph. We have to input the initial graph, which is a set of nodes and a set of arcs, a set of arc A to the machine. So the set of arc A will tell the machine which nodes are connected. For example, if node A and node B are connected, then the arc AB should present in the set A. So the machine can read from that. That is the node A and B are connected.
First of all, they have to find out a node J, which is not in n prime, you know?
Yes, yes.
So first of all, the machine have to write down, have to realize the set minus n minus n prime.
Yes.
Okay, and choose and J belong to that node. That's it. Is that okay?
Yes.
And each J in that set, the machine connect with I in n prime. You have IJ. Is that okay?
Yes.
And then they check if IJ belong to the set A or not, the original A.
Yes.
Is that right?
Yeah, that's what I'm wanting to say.
Yeah. That is the way how they can exclude T. Is that okay? Exclude T and exclude A, B, C, O. See?
Yes.
J just can be what? J in that case just can be D, E, T. And they check if A, B, A, T, B, T, D, T, C, A, T, B, T, C, T are in the A or not. Not. So they exclude T. That is okay. That's just for fun. But I tell you, when you are talking about algorithm, you have to be careful. You have to imagine in your mind. If you want to, algorithm means that something have you to ask the computer to work with for you. Is that okay? So you always have to imagine that how can we tell to the computer so that it can understand. And when you see that this way, the computer can understand. So that means your algorithm is okay. Is that okay?
Yes, I understand.
So we work with the theoretical algorithm. Okay, continue. So the next, now we choose what? Jami.
Yes, sir. So the new tree will include a set of nodes O, A, B, C, and E. And the sets of arc now are O, A, A, B, B, C, and B, E. Since the set of nodes of this tree still do not equal the set n, so we go to the next iteration 5. And now all possible arcs are AD, BD, ED, and ET. We can see clearly from the graph that ED has the minimum length, so we set the node of the new tree now will have node O, A, B, C, E, and D. And the sets of arcs now are the bold line in the showing graph. Next, we also check whether the set n prime equal the set n or not. And because it still doesn't equal, so we continue to the next iteration. In iteration 6, the only remaining node is T, and all possible arcs are DT and ET. And it's clearly that the length of DT is smaller than the length of ET. So we choose the arc DT. Now the set of nodes of our update tree include all nodes of the given graph G. So then we stop the algorithm with the minimum total arc length of the tree now is 440. 14. Sorry, sir.
You are muting the mic, sir.
Yeah. I'll continue. We have tried to generate.
Your mic is tight.
We have tried to generate the minimum spanning tree from the other node of the graph, and we still obtain the same value of the total length, which is 14. And we conclude this presentation by starting several remarks. Thầy ơi, thầy chưa bật mic.
The mic is automatically muted. Sorry. So let's say like this. That is okay at the end. Okay, you work with one example, and I think that it's not quite hard to understand. And the people in the class, you understand already? Any question to the group making presentation? Hello? That is okay, but any of you have any question in the class? Student in the class, you have question, you can ask them. Quick. No? So I have one question I asked to you. The group of making presentation. Hey, suppose that the number there is not the length, and you want to minimize the length, but it is the length, but they is not the length, it's the cost. So if you want to have a spanning tree with the minimum cost, then how can you do? Or the number here is a kilometer, for example, kilometer, and I say kilometer is $100, and find out the spanning tree with the minimum cost. Then how can you do?
I think that we can just find the tree with the minimum length, and then we multiply the minimum length with the cost per length, per unit of length. Then it will give the minimum cost.
Okay, so suppose that they give you directly the cost, and you find out the minimum cost. Then what do you do?
So I'm unsure about what you are concerning. So the direct cost
number there.
So
the number there is not the length.
You mean OA cost $2,000, for example, and AB cost 2,000.
Yes.
Then we just proceed the same with the same algorithm again. I think the case that either OA is the cost or A is the length doesn't matter, or you mean that it has two variables.
Thank you. So you can imagine that this problem is a minimum spanning tree. Is that okay? But it can be minimum cost for the network or something, for the telecommunication network or something like this. A lot of other problems. Are that okay? A lot of other, not necessarily spanning tree, the minimum length or something. Are that okay? So the network problem, network flow problem have a many special case. But I just give you some, yes, this is one very, very special case. And that's good. Thank you. Your group today made a good presentation. I think so. So the mark I give you is 22. And among them, there are two students. Minh Quân get +5 and Trami +2. Okay. So so Minh Quân get the maximum is 25 and Trami is 24, and all the others member in the group is okay. So I say Họ Thương is +1. So the 3 member here, that's okay. Other member have no idea, so they get 22 marks. That's okay. Is it okay? So it is 45 minutes already. So now it's over the time. So we stop our class today. See you next week.
Thank you, sir.
So the next week we will have the talk of the 2 others, and we will start the new chapter. Okay. The new chapter, transportation problem. Okay, the other group, the group 1 and group 3, please come back and prepare carefully. Okay, you have to understand carefully. So bye-bye. I'm leaving.
Goodbye, sir.